So for this work example, we will analyze that is the data set that we are going to be working on. You realize that every time you start with a forward slash and a star, SAS interpret everything that you write in between as a comment. So I've just written a comment there, and comments are normally ignored because they do not contain any instructions to the software regarding whether you are entering data or it's a procedure that needs to be run. So the software is designed to ignore comments. So now we start with our data step, and our focus is to enter the data set that is shown there. So we start our data step with the data keyword, and we give a name to our data set. Let's say call it example one, and then we declare how we are going to arrange our data in the data lines with the input keyword. So we outline the variables in question, and in this data set was for work example one, and it was on magnesium content of certain food products that were analyzed, and then you are required to get the mean for those. So our title for the variable is magnesium content, and then we close. It's only one, and then we start our data lines, and then you realize that the data lines, because you only have one variable, you are only going to have one column of these entries. So we'll have 20, 24, 18, 26, and 27, and then we close our data set. So the data step ends at that, and then we can start our procedure step. We can declare the procedure that we want to use. Now in this particular example, we will use proc means to analyze our data to get some descriptive statistics. All right, so it goes like that, proc means, and then we specify the data in question. Our data of interest is example one, and then we go ahead and now outline the various statistics that we want to analyze, and we want to be given the mean, the means, the standard deviation, the standard error, right? We're also looking for standard deviation, not standard deviation, that's variance. We're also looking for, can even go for coefficient of variation, CV. We can even ask or request for quartiles, the lower quartile, so Q1. You can also request for upper quartile, which is Q3, right? We can also request for 10th percentile, like that, and close it. Now the variable in question is the variable, so we declare the var statement, and the var statement is more useful when you have more than one variable in the input statement. But in our case, we only have one, so the software is going to just analyze data for that one, whether you declare the var statement or not. But we can declare it for the sake of running magnesium content, right? And then we can run that and then see the output, right? And we have there is an error in our data, so we can go to the log and understand what has happened, and it's a type, probably a typo, right? All right, okay, so Alright, so you go back to our code and see what the mistake could have been, and there it is. There is a mistake in writing the means. You're supposed to request for mean. Alright, now we can go back and run and see if we are going to get our output, and there is our output. So we have the mean, standard deviation, standard error, all the others, all the statistics of values that we asked or requested for are provided for, and you can see that. Now the key thing or key point to note in this particular case is that you're given how many decimal places. Those 7 decimal places, those are many. The number looks too large. 7 decimal places. We can decide we just only want a maximum of 2 decimal places, so we add that statement max deck, and we specify only 2, and we run it again and see we are going to have only 2 decimal places specified. The software will round off the values. Okay, so this is the second demonstration, and in this particular question we are tackling the questions that were provided for practice. The first question was data that was conducted by a researcher who wanted to determine the effect of adding flavoring agents on acceptability of yogurt, and you can see they had quite a number of flavors. They had 4 flavors, and they prepared a sample with no flavor at all, and yogurt was rated on a line scale that was anchored between 0 to 10. So you could the panelists could pick any length along the 0 to 10 line, and then that was presented as the data there, and there were 4 replications in total. So when you are provided with such a question, you need to find out how many variables of interest are represented in this particular data set. And you can see in the first instance you have the flavors, different flavors, because this person is testing the effect of adding different flavoring agents on acceptability of yogurt. So the different flavors are representing our independent variable. So you already have one independent variable there, and then you have a dependent variable, which is the outcome, the response variable, and the response in this particular case is acceptability. So acceptability is given as a value, and that is where that's the one that we are going to be analyzing. Now beside this, there is also another variable that is indicated there as replications. It depends on how you look at it. Sometimes it could be an extraneous variable, it could be a variable that you do not it's not of interest in the analysis, although it is important for arranging your data. So we are going to have 3 variables in our input statement specifying which flavor at which replication and what was the acceptability. So three columns in our data set that need to be entered in the SAS. All right, and we can kickstart it. As usual, you're starting with the Open SAS Studio. So we go ahead and open a new SAS program. So in the new SAS program, as usual, we have to declare a data step, or rather input our data using the data step. So the data step starts with the keyword data, and then we give a name to our data set, and our data set we are calling it demo2, right? And we close it, and then we put the input statement, or write the input statement. The input statement is going to highlight the variables of interest in this data set, which also corresponds to the number of columns of data that are going to appear in the data lines. So in our first case, we said we'll have flavor. We'll specify which flavor at which replication, and what was the acceptability value for each one of those, and we will do that for all the different flavors. So afterwards we specify data lines, and then we start now entering our data one by one. So at the end of the day, you'll end up with data that looks like that. So you have mango at replication 1, the rating was 7.4. Mango at replication 2, the acceptability was 6.8, all the way to no flavor at replication 4, the acceptability was 4.8. All right, so now once your data has been entered, then of course we can now go ahead and do quite a number of analysis. And in this example, we still want to repeat, do some discrete statistics using proc means, or the means procedure. So in this particular case, we write proc means, that is the procedure we are using. And then of course we specify the data in question. We can have quite a number of several data sets specified in the same program. So that is the importance of specifying the data set. So although it's only one, we can actually specify and say our data of interest is demo 2, and then we go ahead and specify the statistics we want. We want the mean, you can see that the arithmetic mean. We want the standard deviation, you can see that. You can write STD there. Then you can also write STDR, which stands for the standard error of the mean. That's the standard error of the mean. Of course, you can take your time and read the documentation about the procedure itself. We also want to request for coefficient of variation, percent coefficient of variation. That is what is going to be presented there. We can use request for lower quartile. That's Q1, which is the lower quartile, and the lower quartile, because it's the 25th value, it's also the 25th percentile. And then you can also request for the upper quartile, which is the 75th percentile, right? And then you go ahead and request for many other things like the variance, right? The variance, the data set, and so forth. Now, in the previous example, we said that sometimes we want to limit the number of maximum decimal places that we want on our values that are calculated, and in this case we are using the max dec keyword, and we are specifying only 2. We want only 2, and then we close our proc means statement. Now once we close it there, we can have quite several other statements, and those other statements that come in to specify the manner in which you want to do our analysis. For example, if we want to just do an analysis in which we just want to know the overall acceptability regardless of what flavor there was, we may not need to specify anything. We may just need to just run the data as it is, and once we run the data as that, you are going to get a single value for right now we have made a mistake. So you go back to the code. Now we mentioned something about the input statement, and that variables that are categorical need to be indicated and followed by a $sign in the input statement. So we needed to add a $sign in the flavor and the $sign in the replication, because these are merely categories. They are not numerical data that need to be analyzed. Acceptability is numerical, so there is no $sign for that. All right, so we can now go back and run this data and see the outcome. And there it is. You have a single value, a single mean value, regardless of what flavor there was, a single standard deviation for that mean, a standard error of the mean, and so forth and so forth and so forth. Now suppose we want now to get the the mean acceptability rather for different flavors. We want mango, we want strawberry, we want pineapple. Then what do? Then we just do the same proc means. We are requesting for the same things, but this time round we include, before we run, we include the class statement, and the class statement is going to declare the categorical variable that we want to use. So you are able to specify the categorical variables, variable or variables, or subgroups, or groups groupings for the statistics that you want. So you will be able to do that by including the class keyword. So the class in question in this particular case is the flavor. So we wrote it as flavor. We need to also write it and type it correctly as flavor. Again, if you make a mistake here, you will not get an output. Now, later, because you have already run the data and the data is actually saved in the system, temporarily, of course, if you open the software again, you will have to run the data again so that it can be saved. We can just highlight the procedure for which we want to analyze and then click on run. So instead of it running proc means, submitting the data and then running the proc means before running this other procedure for means, then we can just highlight this and analyze that only. But for now, I want us to see the difference in the results, so we analyze everything again. And there it is. The first procedure was requesting for a single mean. Now we have broken it down and we are looking at the mean for all different flavors. For all the different flavors that were utilized. So you have a mean for mango, a mean for pineapple, a mean for vanilla, for the no flavor added, and for strawberry, and so forth and so forth and so on. Of course, the standard deviation, standard error for each one of those coefficient of variation, etc., like that. So the idea is you can specify the way you want your data to be done. Now, if we had more than one dependent variable, suppose we had more than one dependent variable, then we would come down here and specify the variable that we want to be analyzed. Right? So you can specify one variable or all variables. So if you do not specify the variable, the software will run all the variables that are available in the dataset. But if you specifically state which variable you want data for, then that specific variable will be chosen and you will get data for that specific variable only. All right? So so perhaps you can demonstrate that other portion in which we are specifying the variable. So if for you to specify the variable, you do the same procedure, but this time around you had another statement down there, the var statement declaring the variable that you want to analyze. So you identify the analysis variables and their order. So the analysis variable in question in this particular case is acceptability. If for instance we had another variable like protein content or flavor, rating, and so forth, then we would also list them here so that you get means or descriptive statistic done for also that other variable. Now our dataset only has one dependent variable, which is acceptability, so we don't need to declare anything further than that. Now, suppose you had another variable other than acceptability. We can actually add it. For instance, we also are looking at flavor rating. Flavor rating, it needs to be one word. So I'm using the underscore to join the two words into one. So I'll have to add another set of data here randomly on the same scale, supposing. So 5.6, we'll add another column. We're literally adding another column randomly for this new variable that we have. Is supposing that they also rated the products for flavor, and now we are adding the ratings that they entered. 5.6, maybe 4.5. This data is very random, so it's meant for demonstration purposes. 6.9 from 0, maybe 9.4, 4.8, 5.9, enough, maybe 4.5, 4.3, and this person did not right? So we have already added another flavor. That's another variable called flavor rating. So if we are to carry out the same kind of analysis, we have to tell the software what analysis we want to be done. Now, what analysis we need done, and again also specify which variable we want statistics to be done for. So if suppose I remove all of that and then we work with this. Suppose I request for means for acceptability only. I'll just have acceptability as the only analysis variable, and you can see that the only analysis variable that we have is acceptability. So you have mean for acceptability only. So if I wanted means for flavor, then I'll have to also declare flavor under the var statement, and when I run this data, then I will have also means for acceptability. So this time around flavor rating rather. So you have acceptability and flavor rating for mango, acceptability and flavor rating for pineapple, and so forth and so forth and so forth. Now if you want them in a separate table, you will have to declare them separately. So you have flavor rating coming after acceptability, and when you run the data, these are going to be on separate tables because the means procedure will be run separately for each one of them. So you head up with two tables. Of course, sometimes it helps to have them separated. Other times you'd rather just work with them in a single table because they are all means that you are generating. All right. Right. So we are going to repeat the previous analysis that we did, but this time round we are going to use the Proc Univariate to generate the descriptive statistics. So we are using the same data set, so we are not going to input the data afresh. So in this particular example, we were using data set that was provided for magnesium content in food products, and we wanted to find the means, and of course we decided to check some of the other statistics that you can generate, descriptive statistics. So in this particular case, we just need to write a fresh procedure, which is Proc Univariate. And Proc Univariate, we have to run it on this particular data, which is called example one. And then we want to run this procedure on a particular variable, which is magnesium content. You realize that we don't have a lot of variables, so even if we don't declare it, invariant procedure will still be carried out on that one single variable that is in the data set, and then we run. So ideally we do not need this statement in this particular data set. We would have just written that and then we run. And then of course for starters, we can comment out this data set, all of it, right? So there's another data set, but rather the procedure, so that we only run for Proc Univariate, and then we run and see the output. So the Univariate procedure has already been carried out, and you have some summary statistics here. You had 5 items that were entered, and of course you can see the standard deviation, you can see the skewness, you can see the sum of the observation, you can see the mean of this observation was 23, you remember that, variance is 15, and so forth and so forth. Now there is introduction of skewness, which we'll discuss, and kurtosis. There is also uncorrected sum of squares, coefficient of variation, corrected sum of squares, and standard error of the mean. So again, basic statistical measures are also given there. Can see, so you have quite a number of statistics, including test for location. We'll be talking about how this t-test is used to run this particular hypothesis. And then of course you are also given quartiles. You can see 100% maximum, 99%, and so forth and so forth. You have the upper quartile, 75% percentile, right? And then 25th percentile, which is lower, the lower quartiles, and then some other extreme observations outlined down there. So the univariate procedure can also be used to generate some of these basic descriptive statistics that we can generate with Proc means. Although now when you do univariate, it does quite a number of other statistics beside what you may have requested. And of course, you don't have to request for specifics. They will just be generated for you, and you can pick the statistics that you desire. All right, so that's in the first instance. So we said again, you can actually be able to specify the variable if you have more than one variable in question. So now we move to the next example that we are carried out, the data that we entered on flavor and acceptability that was replicated 4 times, and we added another rating for flavor. So we have 2 dependent variables for us to consider in this particular data set. So again, we are going to comment out all these other programs that we have already run, so that we can better see the outcomes in our Proc univariate procedure. So we start with Proc univariate, and our data in question is equals to demo 2. All right. So the variable that we want is acceptability only. We don't want flavor, right? So we are going to just specify one variable, and then we run, and then see how the outcome will be. So you have the invariant procedure that is being done or carried out on the variable acceptability only, and you can see the mean there, the skewness, the median, the test for location done for that particular variable, and so forth and so forth. The same thing that we had in the previous case, but this time around we have specified only acceptability. Perhaps we can also specify the flavor rating and see how the outcome will look like. And again, we run procedure and see. So there it is. You have the invariant procedure for variable acceptability, and then you drop down and you start the invariant procedure again for a different variable, which is flavor rating, and you can ask for as many variables as you have in your data set, and so forth and so forth. So you see the same statistics that you got in Proc means are also available in other procedures. When you start doing analysis of variance, some of those procedures also generate some of these basic statistics and present them as part of the data output. So again, we see that, but generally, if you just want discrete statistics, these 2 procedures are going to be sufficient. Proc means, you specify which statistics you want, and Proc univariate, you specify which statistics you want. Right.